I'm actually an imposter. I can't spell head and neck cancer. I don't know anything about head and neck cancer, so I'm actually a children's cancer doctor. But I met Tony at a dinner and he asked me to come and talk generally about the challenges of cancer and also the challenges of PowerPoint, which is being worked out at the moment. So what I'm going to tell you about is just something that we can learn about in terms of how we tackle cancer in the round. And I think there's something very common between paediatric oncology, that's my area, children's cancer. We could just do it on that.
Sorry, I've just got to get it back in presentation mode.
That's all right, I can just do it like that.
Okay.
You can see it.
All right.
So in terms of children's cancer and rare cancers like head and neck cancer, and that is, although they're very, very difficult to treat, often because there aren't that many people engaged, that's often a strength as well, because you have a very tightly bound community. So we've heard from Kate, you're going to hear from Kevin, of individuals who are really focused on this disease, and they get together with patients, with survivors, with their families, and it's incredibly potent. And I think we shouldn't underestimate the ability of the power of that to transform cancer generally. So hopefully I can get this to be less weird. So what are the big challenges facing cancer? And this is true of any cancer type. First of all, if we look across the world, about 5 in every 10, the top 10 causes of death are cancer types. So cancer is a major problem across the world. Not only that, actually about 25% of people with cancer are diagnosed in accident and emergency, whereas where I used to work in the US, the ER, and almost all those patients die. And that's pretty crappy. I mean, it's awful that we find those patients only when they present at late stage, and that's something that we really need to tackle. But the other issue is this, and that is the human cost. This is outdated now, going up to 2030, but the human cost and the fiscal cost of cancer is massive. And basically what this tells you is that the current way we approach cancer is completely unsustainable, and it has to be changed. We cannot continue to treat end-stage disease. We can't continue to find patients when it's too late. This is the other big challenge, is that things are really easy in our heads. So we have this kind of completely garbage diagram that we talk about as scientists, where we have the bench where all the clever stuff happens, we have the patients who've been treated at the bedside, and this magic happens where somehow there's this iterative cycle that happens and we work everything out. That almost never happens, almost never. And that's not because it's not an important way of approaching this, it's just that we oversimplify things. And we have to be deeply honest with ourselves and understand how the real world works. Now on the back of that, things are getting better. You've heard some great stories from Kate, and you'll hear some great stories from Kevin. But it's slowly, it's incremental, and it's not necessarily through scientific breakthroughs. It's often through learning how to manage patients better. Actually, the heroes of cancer have often been the nurses, the frontline physicians who just know how to treat cancer better. Not necessarily great breakthroughs, although they do help. So how should we tackle this in a way that actually makes things sort of improve? Now, the good news is we do have a plan. The plan's not very good, but we've got one. So we have the Nhs Long-Term Plan. I can say that because I was partly responsible for writing that, with a good colleague of mine, Martin Gore, who sadly passed away, who was a colleague of Kevin's. But we actually involved with writing that, and the idea of this is to identify cancer as soon as possible. We have another fantastic thing up our sleeves in this country, and that's our industry. This country is phenomenal as a powerhouse of industry, the pharmaceutical companies, and the research that drives that. And if we get these two things to work together, that would be fantastic. However, we live in the real world, and we've already heard about this. And this is a map of inequalities of cancer survival across the UK. You don't have to, across England rather, you don't have to know the details of this, just to know that if you're living in one area that's one colour, you do really well, and the lighter the colour, that changes your outcomes. You don't have to worry about the details. But what it should be is uniform across the country. Why is it that you can travel 20 miles and your percentage points for some cancers drop that much just by travelling 20 miles? That's unacceptable. The other aspect which is challenging is this, and this is just telling you how some of that is accounted for. So here you've got really posh people, like us, who live in posh areas and we do quite well, and then places where I was born, where it's pretty deprived, and actually your chance of survival is pretty crappy. And that's a fact of life that we have to understand and work through in the NHS. And actually what's important to realise is a lot of this makeup and this difference in disparity is cancer. So if we're getting it wrong and we're detecting it too late, and people who live in deprived areas often are detected too late, it's not going to work by simply trying to think in our heads that things are working correctly. The other aspect is screening. Now, this is a cancer type which has had some great success with vaccines, which is cervical cancer, but it's still a major challenge. And we've recognised that even before the success of vaccines, screening uptake was reducing significantly. Mm-hmm. Now, you add on top of that the complexities of inequalities, because there are certain social groups, with certain ethnic groups, that don't take up screening. And in the real world, this becomes a real challenge. So we have a fantastic plan about how to tackle cancer. We think we know how to do it. But then you bump into the real world where people live, where people go to work, where people go to school, where people are trying to earn money, where people are just trying to make ends meet. And cancer doesn't work. So we have to address that challenge. The other aspect in this country is infrastructure. So we all talk about the NHS being rubbish. I can tell you the NHS is absolutely fantastic. I worked for 15 years in the US. If you ever want to moan about the NHS, go and get sick in America. It's terrible. I can tell you that firsthand. They spend more money per head on healthcare than any other country in the world, and their return on investment is pitiful. So their outcomes are really bad compared to how much they invest. The NHS is fantastic, but it's still pretty under-resourced. So right down here, this is just the number of CT scanners per million people. Up at the top, you've got Japan, because a lot of CT scanners are made in Japan. That's why it's top. Down here, you've got Mexico, Hungary, United Kingdom. That's the number of CT scanners per people. And the plan is to scan a lot of people. That's not going to work really well if we haven't got many CT scans. So this aspect of under-resourcing is critical as well. You've got some really clever doctors who treat patients here, but actually this country is, like many countries around the world, doesn't have enough doctors. This is actually a map of consultant oncology vacant posts. About 12% of posts were vacant in 2018. It's got worse. If we looked at clinical oncology, it's even more difficult to find people to fill those posts. So we're also understaffed. We have a workforce issue in this country when it comes to oncology. There's going to be some good news, I promise you. It's not all bad news. So this is the long-term plan. Here we are. The long-term plan is that by 2028, basically 55,000 more people will survive their cancer for more than 5 years. Great plan. No idea how it's going to be done. Okay? It's a great plan, but nobody knows how it's going to be done. Except what we will do is diagnose people much earlier, right? So instead of stage 3, 4, which is where you've got a high chance of dying, we're going to diagnose people at stage 1 and 2, much greater chance of surviving, sort of going from half the patients surviving to about 3/4 chance of survival. And this is part of the plan, filling in the gap between 50% of patients being diagnosed early currently to 75%, and all of this fantastic stuff in the middle. We're already halfway through and we haven't done it. So how are we going to achieve that? So what Tony asked me to talk a little bit about is some of the stuff that we've been doing in Cambridge, but very similar to Marsden. This is not about Cambridge versus the Marsden versus anywhere else. The NHS and actually the academic environment in the UK is fabulous, and it's full of really collaborative groups. And actually we're all tackling it in a similar way, but this is how we're doing it in Cambridge. So when I came back from the US in 2015, and I went to number 10, I actually did knock on the door, and for some reason they let me in. And in 2018 to 2020, we pitched to the government, and that is that to get a step change in cancer survival and quality of life, we need to deploy 4 strategic pillars. If you've got 4 pillars, you're onto a good thing. It doesn't matter what they are, you've just got to have 4 pillars. Okay. So the first thing, which I think is really important, is to be proactive, not reactive. That means you can't let a patient find out they've got cancer when they go to the bathroom and there's blood in the toilet, or if they're having a shower and there's a lump in their breast. That's too late. We have to be proactive. When it comes to head and neck cancer, it's exactly the same. Talk a little bit about how that might be done. The other thing is we need to integrate data much more precisely. So rather than doing, say, just genomic tests, or just pathology tests, or just CT scan tests, we need to use the power of data science at the moment, something called machine learning, which I'll talk very little bit about, and integrate all of that data, turn all of that information into a cloud of numbers that's the shape of that patient's disease, and understand how it changes shape during the course of that patient's disease. And the reason that's important is not only can you say what the patient's treatment should be now, but you can predict what they'll be doing in 6 months' time, or a year's time, in 2 years' time. So what we should be doing today to stop that happening. And then the other thing is to ensure that the NHS is a partner, not a passive recipient in scientific advances. This country, 60, 65 million people, single system to deliver healthcare. Absolutely fantastic. When I worked in the US, I went out the door of my hospital down the street and they didn't talk to each other, different healthcare systems. Actually, you go to the state line, it's even worse. In this country, we have a massive opportunity with a single system of healthcare delivery. And I can tell you the industry is salivating to get access to it. So this can work to support the NHS, but also make sure that we bring those scientific advances directly to patients. And I'm chairing a committee for the NHS at the moment, which is doing just that, looking across all of industry across the world and bringing those advances to patients. But the fourth thing is the most important thing. We need to completely reinvent the patient care pathway. That means it can't be the case where you go to your GP now and say, you know, I've got a sore backside, and then you go back to your GP 3 weeks later and say, I've still got a sore backside, and then you go back again, and then the GP goes, actually, overwork the GPs. They get a lot of stick, but they're terribly overworked. And then you eventually get to the hospital, and there are 50 other people with sore backsides, and they're all getting looked at. And then you're on these massive long waiting lists. And all of the care of cancer is being pushed progressively towards tertiary care to the hospital. We need to do as much early detection as possible, and what we call integrated cancer medicine as close to home as possible. And that's going to require a new kind of hospital. So that was our pitch to government, was we need a new kind of hospital. And I'm just going to tell you a little story in breast cancer, because it's not my area, I'm a children's cancer doctor, but in breast cancer about how we've worked with a foundation in the US and with Cancer Research UK to generate a new way of treating breast cancer or diagnosing it. And we're doing it now in renal cancer, we're also doing it in ovarian cancer. Now, importantly, just to get back to the idea of industry, we get the researchers to think of what is their minimal viable product. If I had to produce something that industry would pay for, what would it look like? And you might think, well, that's really mercenary, we're only interested in patients. Absolutely correct. The bottom line is, unless you do something in cancer research that is turned into a product, a drug or a test or screen, it'll never see a patient. It has to be commercialized for it to see a patient. That's the only way it works in this country or around the world. So what we did is we worked with Microsoft and with NVIDIA, world's biggest AI company, to say we don't just want to look at the tumor sequencing, we don't just want to look at the blood sequencing, we want to look at everything on the patient. We want to look at the pathology imaging, that's looking down the microscope into a digital image, their CT scan, their liquid biopsies, that's taking blood out and looking for DNA that's floating around from the tumor. We want to take all of that information, just like the spectrum of white light, split it out into separate parts, analyze it mathematically, then integrate it, so you can make a single decision for a patient. And so that's the approach that we've taken, taking all of this from these different patient populations and integrating it. So if you think about this in terms of women with breast cancer, this slide's outdated, there are about 1,000 patients now. But if you took 670 patients, we've done that with those patients as they've walked in the door. We've done that sort of analysis on these patients, mainly on the genomic side and the sequencing side, but also including the imaging now and the pathology. Now, prior to us doing this work, only could we sequence 8 mutations in 4 genes, which is pretty rubbish, really. And we could only detect that in 11% of patients with breast cancer and make decisions on patients. So the green patients here, these are women coming to the clinic, that's the kind of decision we can make. We have the information which allowed us to do that. Now, since we've done this, we've now been able to detect the clinical mutations in 88% of patients with breast cancer, just by doing this on the women who walk in the door. So it's completely transformed how we manage these women. And it's not just about us being clever and finding something that we can talk about in a wardroom. But if you're looking for answers as a patient, why have I got this disease? What's happened to me? Is it in my germline? Is it something in my tumor? It doesn't matter what the name of it is. There's something that you can talk to that patient about on what's causing or driving their disease. And then the other aspect which I find particularly exciting is treatment response of patients with triple negative breast cancer has increased over the time period from 40% to 70%. That's across the world. So over the period of looking at triple negative breast cancer, this has been a global aspect. But actually, what's really important is that 40% of those women now have a management decision change because of this interaction. So before it was 11%, and now 40% of those women will have a management change. Now that might mean we need to do more genetic counselling across your family. We need to look across your family, because this is actually something that's not just affecting you. It could be affecting your sister or your daughter, or it could be affecting your mother. And so actually what the team have done is uncovered a whole load of patients who had inheritable cancer that was never realised before in the family. And that's really important to do. So it allows us to start to think about these patients holistically and how they should be managed, just not from a sequencing aspect. Now, back to that minimal viable product, what's really cool is that because we've been able to say this kind of works in these patients, we've now gone to a company and they're now picking it up, and they're going to turn this into a product which will then be used across the NHS. Now, what's really good about that is we can work in Cambridge, where lots of clever people live. I can say that because I'm not from Cambridge. But also we can work with the NHS hospital 20 miles down the road and 30 miles down the road, and we can do it simultaneously. Because if we can get it to work in places which are not don't have the benefits of Cambridge with all the fancy stuff we have in Cambridge, and it works there, then you start to solve the workforce issues. And I just want to give you one example of what I mean by that. Typically in one of these ward rounds, perhaps about 40 patients would be talked about. Kevin will be familiar with that, as will Kate. You know, they have these big ward rounds when you have to talk about patients. But if you can develop an algorithm, computer algorithm, which can read all of that information for a patient, say, this patient needs this, they don't need to be discussed at the ward round. So 5 patients can be talked about at the ward round and really focused on. And the other 35 fairly routine decisions can be made. And so that kind of thing can start to solve the workforce issues. We perhaps won't need as many people in the clinic as we thought we did. So these has a knock-on effects across not just treating patients better, not just giving them more health, not just giving them less side effects, but also solving workforce issues across the country as well. So to do that, this is, I think, my last slide, and I'm finished, is that we've basically devised a new hospital in Cambridge. This is the sort of shameless Cambridge pitch. So AstraZeneca's here, their global headquarters. We're going to build a new hospital here. Boris Johnson's given us £160 million to do this, but we're still fundraising for the rest of that. And it's in our first new 40 hospital build. And critically, it will include research at its heart, and that's really similar to what the Marsden does now, but there'll be, between the wards, there will be research elements, including actually engineering workshops, where they'll be inventing new diagnostics for early cancer. So we have this mathematical powerhouse for these algorithms, this Institute for Early Detection, and our Breast Cancer Institute, which is our largest program. I just told you a little bit about their work. This is my last slide. That's a picture of it. It's not really that. It's a computer-aided design, obviously. This is the Royal Papworth Hospital that does exist. This is Cambridge, and this is Adam Brooks, which is a crumbling district general hospital with fantastic doctors in it. This is the new cancer hospital. So thank you for your attention. I will be around if there's any questions.